Command substitution. Command substitution allows the output of a command to replace the command itself. Command substitution occurs when a command is enclosed with a beginning $sign and parentheses, or with backticks. The form with backticks is older and has two disadvantages. First one, it can be easy to visually confuse backticks with single quote marks. And the second is backticks cannot be nested inside backticks. The $sign and command in parentheses form can nest multiple command expansions inside each other. Let's simulate this. Running date plus %A capital will produce today's day. It's Sunday. If we do echo, today is, then backticks, date plus %A, backticks. This will print today is, then execute the command date plus %A and print the output. Let's run this command. The result is today is Sunday. Using the other form $sign and parentheses, we can do the same. Echo today is $sign parentheses date plus %A. Enter, the output is the same. This is very useful in scripting. Protecting arguments from expansion. Many characters have special meaning in Bash shell. To ignore meta characters, special meanings, quoting and escaping are used to protect them from shell expansion. The backslash is an escape character in Bash, protecting the single following character from special interpretation. To protect longer character strings, single or double quotes are used to enclose strings. Use double quotation marks to suppress globing and shell expansion, but still allow command and variable substitution. Variable substitution is conceptually identical to command substitution, but may use optional brace syntax. Let's try this. I have defined the word host, which equals the result of the command host name. Then I will echo the content of $sign host. It printed the host name of the machine. Now we have host defined as a variable. Let's do echo, then double quotes, some asterisk, host name is $sign host, then asterisk, then close the quotation. This will print to the terminal asterisk host name is, and will replace $sign host with its content, which we defined before the output of hostname command. Let's press enter and see the result. As expected, the result asterisk hostname is then Linux Capsule 1, which is the output of host variable. So, double quotes used here to print some strings Then replace the variable $host with its contents. Let's do echo $user. This is a defined variable and it contains the username currently logged in to the system. The result is Capsule 1, which is here. Let's do echo your username variable is $user. This will work normally and prints Capsule 1 as it's defined in the variable user. If we use backslash just before the $, that means we are going to skip the substitution of $. Press enter. The output is your username variable is $user, and in that case backslash has prevented $, from interpretation and producing the output of $user variable. Use single quotation marks to interpret all text literally. Observe the difference on both screen and keyboard between the single quote and the command substitution backtick. Besides suppressing looping and shell expansion, quotations direct the shell to additionally suppress command and variable substitution. The question mark is a meta character that also needed protection from expansion. Let's try this. I have used echo command, then variable $host evaluate to $host name in parentheses. The result of this echo command is printing variable and print the content of the variable host, then evaluate to, and then run the command host name and print the result of that command. Let's try the same command but with single quote. This will prevent $host from being replaced and $hostname command between parentheses from running. Please note the result. Variable $host as it is, evaluate to $host name parentheses as it is. Let me clear the screen. Back to pattern matching. CD Filenames, ls asterisk a asterisk will print any file contains a in the name. The same ls asterisk 1 asterisk will print files that contain number 1 in the name. ls asterisk dot log will print files that contain .log at the end of the name. LSCA then asterisk files that start with letters C, A, then any number of characters. LSC, then 2 question marks will print any file that starts with C character, then 2 characters after C. LS, then 4 question marks, then number 1, then asterisk will print any file name contains 4 characters, then number 1, then any characters after number 1. Let's see the result. File1.log ls, then AC, then asterisk between square brackets. This will print any file name starts with A or C, then any number of characters. Let's see the output. Let's use the same command, but before A, we will put exclamation mark and see the result. This will print any file name that does not start with A or C, then any number of characters at the end. Let's try this. All files printed does not have A or C at the beginning of the file name. Let me clear the screen. LS square, then AF, then asterisk. This will print any file that does not start with A or F at the beginning of the file name. Let's see the result. There are many pattern matching that we will use during the course, and especially during scripting part of the course. By that, we have finished section 2. Where are the files? Stay tuned with the next capsule, and do not forget the following. Do not subscribe, like, share, or comment if you want to stop this video by you, and if you do not like to spread the knowledge among others that might need it. Please do subscribe, like, share, and comment if you are not that previous person. Thank you and have a great day, Linux lovers. See you soon.